scientific society that represents earth science, science, and engaged their half-million members in the process of discussing the ethics of climate intervention. And that process engaged people from social science, from law, from communication, from the global south, the global north, everywhere. And they had a 45-member advisory committee, and literally tens of thousands of people were engaged in the conversation and in review of. So I bring this up because I want to emphasize that the scientists engaged in this take the issue of and their work builds on this legacy of ethics. So with that as an introduction for you, I'd like to introduce and then I'll go ahead. First speaker is Dr. Kim Bissler, who is a senior scientist in the Oceanographic Institution. He's a marine radiochemist and director of the Center for Marine and Environmental Radioactivity at UNIFOL. He studies the fate of radioactive elements in the ocean and the natural isotopes of these elements, particularly known for his work on thorium. Thorium is a natural tracer of matter that is formed in the surface water into the deep and he's been involved in many of the areas of marine carbon dioxide removal. Next, we'll have Dr. Lee Grab, who is a postdoc at Panelists University. She's also the marine carbon dioxide removal lead for one of Canada's Ocean Frontier Institutes, and that's the institute called mCDR. And has been working with especially the engagement of the public and of interest groups in discussion of marine CDR science. She's also worked on the impacts of CDR and marine CDR. For example, she co-led ICE's workshop on fisheries and carbon dioxide removal. That is, how would fisheries be affected by this process? And then finally, we have Dr. Gerald, who is the director of the Center for Climate Repair at Cambridge, England. And he has for much of his career at the interface of academic research, business, government policy, public engagement. Before joining the center in 2020, he was the director of the Law Institution, and he oversaw the programs of public engagement in science and engineering. So with that, I'm going to turn things over first to Dr. Kim Bissler.
Is this microphone working? Okay. Certainly a pleasure to be in the CDR Pavilion for its first ever existence at COP. But what we noticed right away was we had to turn the background because a lot of carbon dioxide equivalent can involve the ocean. Bringing our blue background into this pavilion is focused on the thing, carbon dioxide equivalent. So a little fun here with the ocean theme that's going on. My work as an academic scientist, I'm a senior scientist at Woods Oceanographic Institution. I'm also something called Exploring Ocean Climate Solutions. We call XCOE. That's kind of a bottom-up. It's a group that kind of basically are interested in the ocean, stress, right? The ocean, 95% of our excess heat, acidification, the human-induced changes of pollution, the nutrients, the fishing, all that putting a lot of stress on the ocean. Yet the ocean is the hero when it comes to really absorbing about greenhouse gas. And we're really here to ask questions like, remove additional carbon dioxide out of the ocean. But maybe it could be enhanced and needs to be studied well enough to put this in context of those natural cycles. So we're here to talk about removal, gigatons, tons, carbon, 3.8 times of CO2 units, 3.8 million tons of CO2 equivalents is 1 million tons of. So it took me a while to come up with a graphic that would scale of 1 billion tons. And I like this one the best in different ways. And if you think of a train, this train's actually in Australia. Each coal car is about 45 meters long. It's still 1 billion tons. And we're talking about human emissions, 10 million tons of carbon a year. Or we want to reduce that about 80% of our emission reduction. 1 or 2. Well, that single train, in theory, is going to, if you have carrying 1 billion tons, that's truly astronomical, right? And the ocean, we won't make the case here, is a place that the ocean holds in millennia. So we have to consider the ocean when we talk about the carbon cycle. And this is just another way to put those numbers in context, too, because it talks reservoirs. All that carbon up in the natural system, and now that we add to it additional each year. Well, the ocean, that's 38,000 here. Right? Plants and soils are doing their best to take up and store carbon. About 50 to 20 times the ocean. So we are having limits capacity if you were to use techniques like trees and afforestation to take up additional carbon. There's just not a lot of place to put it. Big circle there. It's the ocean. A little circle in the ocean is all of human emissions since the Industrial Revolution. It's about 400 of these units. They added land use changes, maybe 800. So 1 or 2% we could fit all of our emissions since humans came on board to protect the system, and you'd only change that number by 2%. Truly significant place to put carbon. That's what nature does. It takes thousands to do that, but that's what's happening right now. So in 2020, I started asked to join a group of co-authors in the U.S. academies to answer this question: can the ocean remove even more CO2? There's a lot there. There's different reservoirs, but how could we purposely do green carbon dioxide removal? We have 6 pathways, loosely defined as kind of the chemical ones on the right, engineers. Things like oceanographic. And then on the left, more the nature-based solutions that include things like fertilization. We're going to talk about iron in particular, and the essentially restoring those ideas big enough to solve our climate crisis. Any seaweed, that's been done for millennia, but scale that up. All of these have some potential. There's a 2 figure there. Might not have heard of that. We can bring up nutrients and enrich the surface water and stimulate plant growth that way. So there are many ways to do this, not just one. It's something like $1 billion investment for 10 years to answer the questions of all of these about their efficacy and their environmental impacts. I think this is well worth the investment, all of them, and we don't really have enough information to pick and choose right now. Some circles, bigger, capacity, maybe a little smaller, but I think there's effort that needs to happen in all of them. Anyway, so this is a recent report that came out in early 2022. There's a group exam. They came out with a 25 report, State of Science for Green Carbon Dioxide Removal. this algae, so sinking crop waste, artificial upwelling, marine emissions, electrochemical, right? So to realize about all of these, maybe it's easy to is have time scales that decades, millennia, and have that capacity. We can get total up so you can get up to these. There's a big difference in energy demand as you move to the right. These are engineered solutions. So we need to come up with fossil fuel feed down those pathways. And I would argue you need to study because hopefully we'll get organizing to the point where we can use some of that carbon-free energy, like electrochemical, other techniques. And of course, knowledge gaps, and that's what's our research program to move ahead. And for technical simple implementation, next, we did this 20, 30 years ago. We kind of know what we're doing in terms of adding micronutrients into the ocean. So here's another summary that's a good reference to the author about different techniques. Iron story about the boat. I went into that academic study and that exercise came out of it thinking, look, we really got to make progress on all of this. And the whole idea about ocean is on the left there under a microscope. It's beautiful, like the green plants. That's a ketosterous diatom. It's a chain of plants, diatoms, that have siliceous shells. Really beautiful shells. They grow very fast. And one of the limits of not sunlight, in many parts of the ocean it's not nitrogen and phosphorus. It's the absence of iron in the ocean. Far away from land, the main source of iron is dust. Very common on land, right? But not necessarily in parts of the open ocean, the high seas, we'll get to that. So what we did, what John Martin really is a hero of this back in the late 70s, is decided that we could do studies in nature by adding iron behind the ship and see what the consequence would be for the growth, the additional growth. So we're altering the natural system. Could we get a phytoplankton more growth because of this limitation? The horseshoe is a response to an addition, and we got close to 4,000 tons. Exciting. We didn't study what happened in carbon, and that's really what the next generation, the next slide's about. But we convinced ourselves that yes, there are many parts of the ocean where iron is a limiting nutrient, and a very small amount, one part iron, about 1,000 parts of carbon. The other techniques, and it's sunlight that make that happen. No energy source, so it's a very efficient way to do this. It didn't answer partly because of tech, because on the ship after growth. So, as you might know, on land, but in the ocean, there's a food web, and when the plants grow, something comes up and says, consuming that carbon as their food supply goes up the food chain, and as those plants and animals die, or they produce fecal material, that marine snow, those particles settle deeper in the ocean. And that concept of a biological human carbon is very relevant here, because iron comes in the top, creates that clean patch, that horseshoe on the last line, and something sinks down in deeper layers from other physical measurements and tracing. That water takes to come back out of the atmosphere. So at least for this technique, we know something about durability. We know that we know less about that cycle, because when you're only out in the ocean for a month, that's not long enough to track the full production and export, we call it, carbon sequestration in the deep ocean. So that's what we're thinking would need to be done in the next generation experiments. And it wouldn't be going out on a boat for, like this for 6 months or something. You'd be using autonomous vehicles underwater, such as drones, things that go on surface, things that move underwater. water, and ships, definitely we would keep it out there. But we think we have the ability, we know we have the ability to run experiments to monitor the ocean. It's also a moving fluid, so we have ways to track where you added the iron with inner tracers. We have satellite observations that can assist us, and we have onboard ships that are onboard these drones, sensors that can measure things like fluorescence, chlorophyll, oxygen. So we have ways to do that full cycle, and that would give us the answer to additional how much that can. We love what they call this a centennial ton of carbon. It's not just how much, how long. So we need to get here, put this ocean pavilion yesterday. So much of this top is about country buildings, right? Those extend out 200 the light blue. Inclusive economic zone. So all the countries, including claims in Antarctica, that actually there are a lot of claims countries, whether that's resolved or not, become a small part of the ocean. 2/3 of the planet is covered by oceans. 2/3 of that is the high sea. And so that global commons, what can be done there commercially, how does research get regulated? So there's an ocean pavilion here that's facing some of those problems. That certainly is relevant to marine CDR. Very relevant to iron. I said very low iron in the middle of the ocean, so that's on these high seas is exactly where we're proposing to do these experiments. And the way to do that responsibly, last line references something called the London Convention, London Protocols, international governance that was put in place 15 years ago. Some of these conventions started. Ways that would allow for at least the legitimate scientific research. We were in that. We had a panel this morning trying to debate what that really means. Does that mean lack of carbon credits or utilization? I don't think it's that strict, but we have guidelines for how to do this under this international agreement that I think help us move forward. Right? We don't have to wait for the final international governance or CDR of all types of sizes. But we can move ahead with the research in these high seas under these international treaties. Second to last thing is that we have a group that's kind of an academic-based group, not just scientists, but social scientists, natural scientists, social science, governance people, looking at this different perspective. Kind of find us at oceanographic.com. From that institution represent this larger group of companies and scientists. We think that moving forward on the research is important. We're not going to tell you whether to deploy or not, but we want that information. The very first thing that group did, Harvard mentioned the codes of conduct. We put together a list of 5 key things that we should be thinking about as we move ahead, even before the science, make sure that comes first. I think first and foremost is we're doing this for the benefit of humans and our environment. This is not a for-profit operation to make as much money as we can. We're not going to benefit the environment and our climate. We shouldn't be doing this. We have to follow those responsible, ethical pathways, following the London Convention, London Protocol. Even if it's not signed into law, even if it's not followed by every country. That's what we would do. We're engaging the public, coming to events like COP, going around to different regional groups, telling them what our plans are. As scientists, we are always committed to open research, publication, peer review literature. You have to do things once. So my very last slide, last half fall kind of sums up a lot of what I hear. There's a lot of kind of hands off the ocean. We shouldn't be trying these things, but I think that's relative to what we've already done to the ocean. That shouldn't be an argument for not trying out many different methods, see how far we can get. So it's always a trade-off. They will have impacts. We intentionally will change the ocean if we do any of these. If we're not changing the ocean, they're not working. So let's admit that right up front. science, we have to do this incomplete to really know what happens when we get to a building. That's a difference in scale from the smaller scale we have to do right now, the field trials. So field trials and help make those choices. We think that those field trials, in the case of Oceanographic, 13 at least, in the late 1990s, 2000s, will be a change to the old reset. We don't think the impacts were permanent from those field trials. We're ready to move ahead on them with the new technologies, and we can do that under this permitting that's allowed under the London Convention. And maybe the last couple words we've done is, I have to keep repeating, this goes along with fossil fuel reductions, and we need to consider multiple approaches. The half glass full, half empty, again, goes back to people who are saying, okay, this is a waste of time, or you're harming the ocean. I think it's too early to pick. We should just try and work together with it. They see people here online.
Okay, that works. Well, thank you, Ken, and thank you, Margaret, for opening the panel. And so I'll start by talking a little bit more about a program that I've been the research lead of, so Converge CD, and the perspective of research that we've taken to think to the. I'll get a little bit more into some aspects that are more unique to CDR, but the science, as an advocate of science leading the way, but underlying the science, we have a lot of interdisciplinary needs that also need to be considered alongside. So what we've done here is we've built a program with 4 main pillars across science and data, engagement, policy, and business and economics. And across these 4 pillars, we're working to identify what the biggest needs are for mCDR. And so we've just gone through a co-design process of our research agenda in order to identify what should we, as an academic entity, focus on. Is that we are going to then prove in each of the fields, each of the pillars, to then take these projects on. And so this here is a pretty complex figure, and so I'll walk through it with you. We've been working with community members, PIs, principal investigators, Dalhousie, as well as mCDR entities interested in mCDR in order to identify what we call the winning conditions for mCDR. So those are on the found when consulting the winning condition, science and data. In addition to thinking about the carbon, we're hearing that community and those interested in those mCDR are really focused on what other benefits are there in addition to removal. So benefits as well as thresholds. How much can you hit a threshold where environmental feedback is more of a net negative impact rather than a net positive impact? There's also a big focus on monitoring, reporting, and verification. And what we've been hearing is that, especially from the communities, they're interested in the environmental impact. So the environmental impact assessments, or EIAs. And this integration of environmental impact assessments into monitoring, reporting, and verification is really critical in order to be able to assess what these differences are in terms of the net impact of mCDR when considering, in addition, those impacts in addition to carbon removal. A simple read to understand what are the options with mCDR. And sectors such as current and are there economic opportunities for them? So when we focus on the policy side, we have hearing that there's a lot of ongoing focusing on the governance pathways. And when we think about the integration across, as I talked about for the science and data, there's a lot how to integrate MRV as well as environmental impact assessments to potential markets and into regulatory practices as well. And then the business economics side, we're working with community members. So a few of these projects within our larger project are led by First Nation members. And from there, what they brought forward was their interest around economic, thinking benefit economic, community economic benefit agreements and benefit sharing models. So are there opportunities for them to be co-owners of the project? Or if a project into their land, what does it look like to share the profits? Can they understand and assess the potential economic gains and the environmental impact if they invest in? And or land recognition, is there a piece of land that we should try and get another piece of land because it has more potential to be used with mCDR techniques? And so in identifying these winning conditions, we then were able to form deliverables within our project and think about how these deliverables interconnected across the 4 pillars. So these lines here in the center, they looks pretty complex. It's actually purposeful. And I do not have the exact deliverables stated for all of the sections because we're actually recruiting postdocs to work on these projects. So I'll leave that for them to share once they get. But in the red areas, this is the project that I'm starting. And so, for example, I'm going to work on building biogeochemical models to identify co-benefit thresholds. And we can think about exactly how this deliverable is collaborative with the other future coordinates that we have working on these other pillars. And then together, we also can think about what are some collective shared deliverables. Things that the community is interested in, like frameworks for how do you build community economic benefit agreements or practices for engagement that a lot of companies are just knowing about, like best practices and steps to take in order to build these types of co-design methodologies within the community. And so to go a little bit deeper in like what does this actually look like? So an example, this is from my research that I'm focusing on. You take a question that typically, a baseline. So how do nitrogen feedbacks oxide is about 300 times more potent than carbon dioxide? How do these feedbacks production of dioxide bring carbon dioxide removal and the monitoring verification of it impacts? This is a question that can be answered from a biogeochemical model by asking science questions. What we can do is we can take that, colleagues, and from the very beginning, so this is before we started the research, identify pathways on how it interacts with the engagement, the economics, and the policy. Make sure that we're asking a question that actually answers these other pillars. So for example, this is a question that actually from with First Nations in Canada. And so they've been asking more questions about the other impacts rather than carbon removal. We also are developing community workshops to educate and provide outreach materials to additional First Nation communities. This is led by from the Wolstiki Nation in Atlantic Canada, which is and want to bring these scenarios for them in order to come back with the policy. Our policy team, in order while they're looking at potential regulatory pathways in Canada, how do these co-benefits get incorporated in the regulatory processes? So, for example, permitting. Thinking about, are there permitting processes that should be these greenhouse gases? If you remove carbon dioxide, are you actually emitting more nitrous oxide? Counteract amount of carbon that you think you are, or have a different, but maybe it's greenhouse gas removal than you thought, or greenhouse gas removal, or maybe there's certain area where it's more effective to minimize this feedback. And on the economic side, we're working with value. So this is just one example of how these co-design methodologies are going to space. The last you can imagine that each of the different pillars has a graphic similar to this. And so another conversation that has been going on which is International Council for Exploration, co-leading workshops, a pending working group forming to look at the interaction between mCDR and fisheries. This is a really important consideration for marine carbon dioxide removal that is scientists and NGOs. And we started with the workshops. It's just intersection between fisheries. And now developing different frameworks to try how do you engage fisheries with the mCDR sector? How can we overlap, minimizing the risks associated with it? We actually have a now in the theme set, but by February 6th, more papers that are thinking about this intersection between fisheries and mCDR. But the first paper that we wrote as a steering committee focused on why should we engage fisheries from our perspective. And so these are just a few recommendations. So synthesize the current state of knowledge and relation. Conduct early and meaningful engagement. Leverage